Venice is a town that should never have existed. With its 124 islands, innumerable bridges, and its 176 canals built in the middle of a gigantic swamp, La Serenissima is an example of the boldness of the human spirit and its capacity to tame nature.
In my view, there are many beautiful towns in the world, and then there's Venice.
Every year, over 30 million tourists come to admire the palaces along the Grand Canal. True superstructures of their times, they were built using techniques found nowhere else in the world. And if La Serenissima seems to float upon the water, it's because, in fact, Venice is an upside-down forest, built on 10 million posts driven into the mud. It defies all the laws of architecture. But man has drastically changed the lagoon of Venice. Industrialization, ground subsidence, huge increase in the number of motorboats. The 20th century has put the city of the Doges in jeopardy.
This environment that remained unchanged for thousands of years has been destroyed in 30. It's an absolute and total disaster.
Because of global warming and the rising water levels, Venice more and more frequently literally has its feet in the water. So much so that many people think that the city of the Doges will eventually disappear.
It is Venice's destiny to be submerged, that's for sure.
So to save Venice, some incredible ideas have come to light. One especially, the MOSE project, is a totally unique system of barriers designed to block the high tides that threaten to engulf the town.
We are creating one of the biggest work sites in the world. Obviously, it's a huge challenge for us.
How did men master the lagoon and build on it one of the most extraordinary towns in the world? What are the dangers that threaten the city of the Doges? Will Venice be saved? Or will it end up at the bottom of the sea like the mythical city of Atlantis? This is the amazing adventure of Venice, a unique city, but a city that is disappearing. The story of Venice began more than 1,000 years ago in the middle of a vast stretch of water in the north of Italy on the Adriatic coast. This is the lagoon, 50 kilometers long and 10 wide. It's made up of brackish water, sand, and mud. In short, it was a place that was hostile to human presence and of no interest to anyone. But this all changed in the 5th century, when Europe was set ablaze by hordes of barbarians. People living on the coast sought refuge in the lagoon.
The lagoon provided natural defenses. It was very difficult for enemies to sail their boats and find their way. Only the people living there knew where the canals were, so they had no need for walls to protect them. That was a great advantage.
The first paradox is that the Venetians, who would later conquer the world, began their story as refugees in the middle of nowhere with no drinking water. To build their first houses, they had to use whatever came to hand.
We have a few pictures that help us to form an idea of what the Rialto island might have been like. Rialto was the center of town, with thatched wooden huts.
The first buildings on the ancient site of Venice were in the most stable areas of ground. For example, Rialto comes from Rivo Alto, which was a high, solid bank. Dorso Duro, the name comes from the fact that it was a more solid piece of land. The early town was built on places like that.
But that is still a long way from La Serenissima that we know today. It wasn't until a few hundred years later that the little wooden huts were replaced by the impressive Rialto Bridge and the palaces that surround it. The first Venetians lived on small islands separated by water. Each one was a little village designed on the same lines. A square, dwellings all around it, and in the middle, the church.
That explains why we have so many churches and small squares. They were the centres of the ancient micro-villages.
And through the centuries, these islands were linked by improvised bridges, often built on the slant. But during the 7th century, the Venetians started to be short of space. The solution was to build new artificial areas of land on the water. But building on the bed of the lagoon was anything but easy. The bottom is composed of sediment and mud, and a lot of currents flow through it. In short, ground that was moving all the time.
Here, even from a geological viewpoint, we are between sea and land. The factors are discontinuous. On the one hand, the rivers bring us sand from dry land. That forms a certain type of ground. Where there are reeds, the ground is made of peat, which has quite a different density. Venice itself was born on this multitude of geological strata on very varied type and solidity, and that caused problems. Today, when we see a church tower leaning over, we know it's because it's standing on several different strata. So the tower tips sideways.
The church towers of Venice lean, but they don't collapse. So, what tour de force did the Venetians dream up? How did they manage to make the ground firmer? The builder's secret was ordinary wooden piles. Hundreds of thousands of them were driven into the bed of the lagoon. And miraculously, the builders discovered beneath the sand a layer of caranto, or clay. It lay at a depth of 3 to 8 meters below sea level. The piles had to go down far enough to be driven into the clay to stabilize the ground.
Stabilizing the ground meant marking out the limits of a certain zone with piles. If I take some piles and I drive them into the mud and then soak it all with water, the ground between the piles will compact and stay more solid than the ground that's outside the perimeter. It's held in place by the piles which stop it being washed out. That's the theory of ground stabilization.
That's how the Venetians created artificial areas on which the town could grow, with sand from the lagoon held in by wooden piles. And the builders made another stunning discovery. Wood driven into the mud doesn't deteriorate.
It's the poles that are underneath the buildings in the mud, is that they're permanently in oxygen-free environment, so none of the microbes that would normally decay wood can get into them.
The wood undergoes a process of mineralization. It becomes as hard as stone and can remain intact for centuries.
The most famous Venetian monuments were born on land consolidated in this way. St. Mark's Square with its bell tower that alone rests on 100,000 piles. The foundations of the Rialto Bridge, 12,000 piles. And even more impressive, the imposing Basilica La Salute, built entirely of marble, even more than 1 million piles. Mind-boggling figures.
Today there are 8 to 10 wooden piles per square metre. The town was created on these piles. You might even say it's an upside-down forest. The piles fulfil the function of roots, and there are an incredible number of them.
It's estimated that in all, 10 million piles were driven into the sands of the lagoon, the equivalent of 1/3 of the Landes forest. They're mainly oak and larch that are reputed to be very strong and were brought from nearby coasts. To stabilize their ground and to bear the weight of the palaces, the Venetians spared no expense.
A study shows that the foundations account for half the cost of the building. The other half goes to the superstructure of the palaces. This means that the submerged part costs as much as the part above the water.
The town's 400 palaces all rest on these unique foundations. Built from the 11th century onwards, they are the true superstructures of their time. To make these palaces last in an unstable and moving environment, the builders called upon all their genius because they faced a triple challenge. To protect the buildings from the saltwater tides, to build the lightest possible structures on sandy ground, and to take into account the movements of the lagoon bed. This is the brilliant idea they came up with. On the piles, the Venetian architects placed a first stratum of wooden flatbeds. Then there were several layers of bricks, on top of which the builders had the idea of laying a special white stone imported from the Dalmatian coast, Istrian stone. This was the first line of defense against the movement of the tides.
That deals with the interface between the water and the air. That resists an infinitely long time because it's not permeable to the salty water.
Resistant and impermeable, Istrian stone served as a protective wall. It easily stands up against the comings and goings of the salt water. The height of the stone layer was calculated in function of the height of the tides, and therefore it prevented the water from breaching the load-bearing walls that were made of bricks and were much lighter. The rule of the time was, do not build above 3 floors.
They understood when they were building that they couldn't make it too heavy because they knew that it was all relatively fresh mud in geological terms that still compacts and causes subsidence.
Slender columns and large windows. Through their concern for weight, the architects created a unique style that was elegant and like lacework, the typical Venetian style. All they had to do now was find the way for the building to adapt to the moving ground of the lagoon.
The movements of the ground and of the water are variable, so the buildings couldn't be rigid.
Here too, the Venetians found shrewd solutions using the materials that they had locally, in particular lime mortar. It was used for building brick walls. Its advantage over cement was that while it was used like cement, it remained supple.
Lime was probably the most important material because it's adaptable. It's not rigid like cement, it can adapt. The aim was always to build, create what they had in mind, but something that could move over time.
Second example, the floors between the levels. They were made of wood, a material that is flexible and that can transform. And to ensure the flexibility of the walls and floors, the builders came up with another trick.
The beams were rested on the walls, but in such a way that they could move.
Flexible, supple, and adaptable, the Venetian building is like a living organism that changes shape according to the whims of the unstable foundations. Today, the palaces bear the stigmata of time. Some balconies are distorted. Sometimes fissures appear inside the buildings.
There has been a bit of subsidence. Some facades have twisted and leaned a little. But no palace in Venice has ever collapsed.
Venetian engineers design their buildings so well that they can even absorb the impact of earthquakes, which are common in the region.
I remember my father-in-law telling me about when there was the earthquake in Friuli in the 1970-something, and Venice felt the shocks of that very strongly. And where we live, There's very tall, big arched windows, with lead holding the panes of glass. And he said that the windows just moved like the sails of a boat and then came back in place. Not one of those little panes cracked and fell out.
Every palace has a well in its courtyard. The ingenious Venetian architects solved the freshwater problem with the invention of a sophisticated system for collecting rainwater. The water runs through these small holes into a tank where it's filtered through very fine sand. The clean water finally runs into a cistern from where it can be drawn off.
The idea was also to recuperate rainwater from the gutters on the roofs to fill the wells in the squares. It was really a very ingenious system that you don't find anywhere else in the world. And those wells were still functioning in Venice up to the beginning of the 20th century.
The wells feature in all the squares in the town. The architects dug 900 in all. At the end of the 15th century, 170,000 people were living in Venice, more than there ever have been since. La Serenissima was then at her peak. Thanks to her powerful fleet built in the town's arsenal, Venice dominated the Mediterranean. From Tunis to Beirut, the city of the Doges was the only colonial power of the Middle Ages. Venice was like a fish in water.
We have documents from chroniclers and ancient historians who say that water must be protected because it's our most precious community property. This is the reason that there were lagoon specialists and canal specialists.
That was the challenge to the Venetian magistrates, to preserve the lagoon and the water surrounding their town. But towards the end of the 15th century, the authorities made a frightening discovery. Their beautiful fish was about to be suffocated by the sand. How could this have happened? What massive works would have to be undertaken to combat the silting up? How would the Venetians of the 15th century save Venice? The danger came from the rivers that flowed into the lagoon. It was beginning to get silted up with the sediment that the rivers always carried along.
The canals were getting too shallow for the bigger ships that, were important for Venice as a trading empire, and also for its military expansion. It needed to be able to have the ships come and go with the, with their soldiers and mariners, etc.
But this should be very dangerous for the city, survival itself, because then this could be a possibility for the enemy of Venice to attack the city from inland.
How would the Venetians cope with this whim of nature? In the course of long debates in the Palace of the Doges, two visions of the town's future were in opposition.
The people believed that the life of the city should evolve along the lines of how the lagoon was changing. So if the lagoon was silting up, then Venice should think of a future for itself and transition to agriculture, for example, because, they discovered rice. I think they already knew about corn. And then there were other people in the city that said, no, we're very good at sailing. We need to maintain Venice as a maritime republic, and therefore we need to do things to stop the lagoon from silting up.
In the end, it was those in favor of water who carried the day. The idea of the Grand Canal turned into a field of corn was unthinkable. The water had to be saved at all costs, and to do that, they had a wild idea: to reroute the Sile and Brenta rivers so that they would empty their sediment outside the lagoon. They were about to achieve an amazing feat, to dig 300 kilometers of new canals with 15th century tools, gigantic works which would take 100 years.
From that time, the lagoon is no more, let's say, really natural anymore, because the present shape of the lagoon is the result of a big effort that men that live in that area put to keep the lagoon in the same shape as it is.
Thanks to these major works, the Venetians managed to preserve the maritime identity of their town. But the water that the Venetians wanted so much to save ended up by turning against them dramatically. Because other, even more serious problems were lying in wait for the city of the Doges. The subsidence of the bed of the lagoon on the one hand and the rise in the water level on the other made a dangerous combination. How were the Venetians going to deal with this new threat? What unheard of technical exploits would they have to accomplish? Today, La Serenissima still stands proud of the water. But the lagoon has changed. Cars, trains, and even airplanes were further added to the maritime traffic, which increased tenfold. And there would soon be factories, a refinery, a power station, and a shipyard. With the 20th century, Venice joined the modern world. And it was the lagoon that paid the price.
We're seeing the drainage of vast areas of the lagoon in order to build industrial zones. The port of Marghera is an example of man's intervention. The drying out means the cancellation, even the annihilation of the aquatic environment.
Built from 1917 onwards, the industrial area and the roads to the airport have taken up 1/10 of the service area of the lagoon. But that isn't all. To facilitate the movements of the great oil tankers, the entry to the Malamocco Inlet was widened up to 900 meters. And a new canal was dug right in the middle of the lagoon.
Instead of the ships following the natural path of the channel, which was quite convoluted, they dug this straight highway across the lagoon, very wide and very deep.
It's just like a motorway that drains much too much water towards Venice and threatens the city of the Doges.
The water no longer spreads out in the same way. The natural canals are disturbed by the tanker's channel that absorbs all the currents. It's a hydraulic disaster. The ancient natural environment has been destroyed in just 30 years.
And that isn't all. To satisfy the needs of industry, 8,000 wells were dug to pump water from the water table, which is just under the foundations of Venice. In the 1950s, up to 40,000 cubic meters of water were drawn every day.
This generates a decrease of the pressure.
By pumping, we reduce the pressure in the layers of sand. And when the pressure goes down in such a special and fragile soil as there is in Venice, the geological strata are compacted, with the result that the ground subsides.
It's that right now we call it subsidence, land subsidence.
The result was that Venice sank 15 centimeters in only 30 years. The lagoon, mistreated in this way, would eventually avenge itself on the Venetians, and the town itself paid the price. On November 4th, 1966, a particularly powerful high tide caused the water to rise almost 2 meters above sea level. It was the worst flood that the Venetians had ever known.
The water started to rise, and when it should have started to go down, after about 2 hours, it didn't. Quite the opposite. It just kept rising. Communications were cut off. We had no radio, telephone, or electricity. We were really frightened that day.
80% of the town was flooded. St. Mark's Square was under 120 centimeters of water for 30 hours. The tanks of fuel oil and diesel overflowed and polluted the town. But in all this misfortune, there was one piece of luck. Not one person was killed. But nearly 5,000 people found themselves homeless that day.
The Venetians and the whole world understood that day that if you attack a natural system, the system will fight back.
Among the first measures taken was that they stopped pumping from the water table. But the damage had been done. The 13 centimeters lost would never be recuperated. And a further threat was imminent: global warming and the rise in sea levels. This caused the water in the canals to rise 10 centimeters. In all, Venice lost 23 centimeters. The figure can be seen on the facades today.
La zona più esposta
The area that was most vulnerable is the one that is green today. It indicates the rising and falling of the tides. It's not the king tides that do most damage to the town. It's the everyday tides. The water comes and goes continuously.
Nowadays, with every tide, salt water reaches the brick walls. An upheaval that challenges the precautions taken by the architects of the past. The Istrian stone that formed the impermeable foundations of the palaces is no longer of any use as a protective ring.
The water's always against the brickwork, and the bricks are very permeable, and the water evaporates from the bricks, leaving behind the salts, which crystallize. And as salts crystallize, they expand in volume 12 times, and that is a very kind of slow way of, you can say, exploding brickwork.
The salt water also attacks the lime mortar. As a result, the bricks fall out and the structure as a whole is weakened. To reinforce them, these iron barriers are springing up in the town's canals. The owners have to pay the costs of restoration, but the town council can't make them do it. Today, a third of Venetian palaces are damaged and need renovating. But the daily tides are not solely responsible for the damage. Motorboats are the real problem. Their movements create extra waves, not only on the surface, but also deep down.
The coming and going of boats is very bad for the walls. With its propellers, a boat creates extra movement in the water which erodes the walls. And once the wall is eroded, the waves even attack the ground. As you can see, boats go past every minute. It's their number and their frequency that put a wall at risk.
The water seeps into the cracks, jeopardizing the whole structure of the building. It even gets to the compacted earth between the piles, foundations that were designed over 1,000 years ago. Today, they are in danger too. To limit the damage, Venice has imposed a speed limit of 5 kilometers an hour on all the vaporetti using the canals. What's more, huge liners come into the lagoon every day and unload their hordes of tourists.
These big ships move huge volumes of water. You know, that's Archimedes' principle. There's still a volume equivalent to the volume of the ships that gets moved. And when they're in the Giudecca Canal, in all the lateral, narrow little canals, the water level rises and then goes down again with the passage of each ship. It's like an extra tidal excursion, but not a tide that comes and goes over 6 hours like the regular tides, but a wash of water that moves within, you know, over tens of seconds or minutes. And that's very detrimental to the building foundations.
Between the subsidence of the ground, the rise in water level, the waves from the motorboats, Venice is threatened from all sides. To save the treasures of the city of the Doges, there's only one solution. Drain the canals so as to undertake major works.
They're working on drained sections of the canals about 50 meters long, no more. It's important to know that draining the canals causes subsidence of the geological strata, and this can lead to damage to the nearby palaces. You can never keep a canal dry for more than 3 months.
Today, the town is treated with modern methods. Chemicals are injected in the place of lime mortar to consolidate and rebuild the walls. They prevent the water from seeping into the bricks, and it all has to be done by hand. So even restoring the parapet of this small 18th century bridge takes on unexpected proportions.
How are you going to do it?
I think we'll have to make a cast and create an exact replica that we can give to a specialist.
Everything must be copied perfectly, right down to the finest detail, like this one. Venice is like that. It's demanding. So to make an exact replica, they'll have to call on a specialist who will do the job by hand, using traditional methods. There are no machines to do it. There are no machines specially designed for Venice.
That's why renovations in Venice are more expensive than anywhere else. Today, the town has barely 2 million euros a year to maintain its buildings, whereas 13 million are needed. The water that gave Venetians their glory and their wealth has finally turned against them. Today, 1/3 of the ground floors in the town have become uninhabitable. And the floods, the acque alte, are more and more frequent.
The last 50 years, I would say, the city has experienced really a big increase of the frequency of this high tide. And so if in the past the frequency is really 1 every 10 years, let's say, more or less, now the frequency increased a lot, up to 4 or 5 times per year.
These figures could well turn out to be higher with global warming, which is causing the inexorable rise in sea levels.
Venice's destiny is to be submerged. That's not my prediction. It's foreseen by the people studying maritime and climatic questions.
The prediction that has been done up to the end of this century, they say that the sea level should be rise by, let's say, between 20 and 40, 50, 60 centimeters.
The idea of the city being swallowed up no longer seems a mere fantasy. So Venetian genius will yet again prove itself with a colossal project to save Venice from ending up at the bottom of the sea like the mythical city of Atlantis. The response of the Italian authorities to prevent Venice being swallowed up is the MOSE project. It's a simple idea. It involves blocking the huge masses of water that come from the sea into the lagoon by the 3 access channels: the Lido Inlet, the Malamocco Inlet, and the Chioggia Inlet. The Italian engineers have dreamed up a system of retractable barriers. In the event of exceptionally high tides, they will be raised to stop the water flowing in. In short, a gigantic plug.
This kind of barrier is unique in the world because it answers to question very unique, because Venice is extraordinary, so Venice is unique and has a unique solution.
The basis of the system consists of gigantic 25,000-ton chambers as big as 7-story buildings. Using custom-built systems, they have been sunk to the beds of the inlets. These concrete giants form the basis of the mobile doors. The MOSE project was launched in 2003 and is now in the final phase of completion. At the Malocco site, about 20 gates are still waiting to be installed. Alberto is the technical team leader.
These are the next gates to be sunk to the bottom.
Steel giants that weigh more than 330 tons. They are of titanic proportions, 28 meters long, 20 meters wide, and 4 meters thick on average. But each of these gates is calibrated and adapted to the seabed.
The Malamocco gates are larger because the seabed is lower, at 14 meters. At Chioggia, it's only 12 meters down. However, the Malamocco gates are 50 centimeters thinner than those at Chioggia, because the Chioggia gates have to resist a much greater pressure of water. When Alberto gets into one of these gigantic gates, it's as if he were going into the hold of a ship. And yet, this vast space will be filled with water. When the gates are not in use, this entire space is filled with water. These 4 red tubes carry air from the compressors from the technical unit right at the bottom of the gate. That's what gives the first impetus that raises it. The air pressure pumped by these tubes pushes the water, which then escapes through special openings. So the door rises and holds back the tide. If we get a 1.20 meter tide, the barrier will be filled with 1/3 air. If we need to hold back a 1.60 meter tide, or even 3 meters, as has been envisaged, the gate may be filled with air, up to at least 2/3. Alberto and the engineer's job consists of putting the gates on the tanks. Closely monitored by cameras and a GPS system, the steel giant descends to a depth of over 10 meters as it gradually fills with water. The hinge has to be fitted absolutely perfectly so that it can be permanently fixed. This takes 6 hours of concentration and tension. Every time, it is a real feat. Alberto's men cannot afford to make a mistake.
In total, 78 gates will end up on the seabed.
This system has been dimensioned considering a high tide over 3 meters. It means 1 meter more than the exceptional event occurred in 1966. And it has been dimensioned considering also the worst scenario of sea level rise. It means 60 centimeters.
Once the works are completed, the gates will be monitored 24 hours a day by 50 technicians. They will be working in service galleries below water level inside the tanks. MOSE is a magic solution for some and a burden for others. The project polarizes the Italians because the works have dragged on for almost 15 years. The final implementation date has been put back time and time again, and the works have swallowed up the vast sum of 5.5 billion euros. And this cost could still rise.
We don't know if it's going to cost 10 million, 100 million, 1 billion. I mean, we don't even know if they're going to finish it and get it working. But that they don't know either how much they're going to need to spend on keeping it working is very alarming.
The MOSE project must be accompanied by something else. In my opinion, it's inconsistent to want to protect the town against king tides if you don't at the same time maintain it.
As of today, the survival of Venice rests on the MOSE system and the hope that it will prove to be effective. But the retractable barriers won't be able to solve all the problems. They won't stop either the subsidence of the ground nor the maritime traffic. And they won't prevent the slow deterioration of the buildings. Venice's future is looking gloomy.
There are even people who are suggesting that we separate Venice from the lagoon. In my view, it's already pretty radical to separate the lagoon from the sea. But let's do it. Let's turn Venice into a museum. Let's put it in a glass bubble, get rid of all the Venetians, and the problem will be solved.
But fortunately, the Venetian people's imagination knows no limits when it comes to their town. The latest idea is to reflate the subsoil to raise the level of the town. It's a seemingly crazy project dreamed up by researchers at the prestigious University of Padua.
We put 10 wells or 12 wells on a circular shape with a diameter of 10 kilometers, and we inject water into a quite deep aquifer. We select an aquifer system that it is located between 600 and 1,000 meters below the lagoon bottom.
Incredible. Using injections of water to raise a third of the lagoon, a groundbreaking idea never before attempted. These 12 wells would pump 50 liters of salt water per second to swell the sandy subsoil of the lagoon. The researchers are envisaging a progressive elevation of 20 to 25 centimeters in 10 years, that is 2 centimeters a year, resulting in a lowering of the levels in the canals. Unfortunately, this method is not without risk.
You cannot do it in a shorter time. We don't want to generate any fracture, and for this reason we have to inject at a safe rate.
Swelling the subsoil is perhaps the way for Venice to regain the 23 centimeters lost on the seabed. For the moment, this futuristic project is still in a drawer, waiting for finance for the first full-scale tests. In the future, will Venice have to be surrounded by high-tech megastructures in order to keep its head above water? Is that the price to pay so that the generations of centuries to come will be able to admire it? When will we see the next spectacular project that will bring the miracle solution? One thing is certain: No one wants to see this extraordinary town disappearing under the waves. La Serenissima will always be able to count on the enthusiasts who will take up the challenge to save her.